Łukasz is going to talk about the future of deep learning. He doesn't need really an introduction. Łukasz co-authored Attention is All You Need, worked also on TensorFlow, was at Google Brain before, and actually is a Pathway supporter. We're very grateful for having you here, and here we go.
Thank you very much. Thank you for the introduction. I had the pleasure to work with Jan way before deep learning was a big thing. So for here, I just want to talk a little bit about the deep learning past and future. So I'll tell you about like my path in deep learning very quickly, and I do think this gives like some thoughts of what will come in the future. So it's hard to be a deep learning researcher. I was a theoretical computer scientist before that, and it's much easier because you do the same thing for 20 years. You do like maybe different theorems, but it's in the big picture, it's the same thing. Deep learning is not like that. Every 2 years, you do a totally different thing. And so the big question is like, what is the next thing for the next 2 years? Because like, when I started deep learning, that was about 10 years ago, like you had to show to people that this neural network thing works. They did not believe. Then there was this like whole architectures thing, you know, how do you take the best architecture? Then there was like this, oh wait, but instead of training like on one thing, like it used to be before, like recognizing cats, maybe you should train on all of the internet. And that was the big thing. And then it was like, oh, but maybe you should invest $100 million in your model, but that requires something different. And then came this like RLHF and like, oh, it actually can answer your questions. And what will come next, we don't really know. But I want to show you that through all of this, there is some very important thing that just comes again and again. So when I started deep learning around 2014, I was working on parsing, and so in 2014 this paper came out, which I think was the inspiration for me definitely and for a lot of people, which showed that deep learning can translate from English to German and French. So you just took some data, this was in RNN time, and it could translate, and people at Google Translate were like, yeah, but it will never get as good as our current system. Like we have the, you know, it got to like 30 blue, but we can do better. So these were RNNs, as I said, and my first paper was Grammar as a Foreign Language, which was, you know, not a very big discovery. Namely, like if you know how to translate from English to French, you could also translate from English to a parse tree of English. You just need to write the parse tree as a string. That's basically the whole paper. Then it was always hard to implement these things. Now it's a little easier. And you know, the people who did parsing at Google said, well, like, yeah, but it will never be as good as that parse. But of course, this is the problem with deep learning, that, yeah, maybe indeed, if you trained just on this data, which was called longitudinal, it was not very good, but then if you added data and compute, it got better, right? And then it was better than all existing parsers, and of course now it's better than all existing translation systems. And this is one pattern in deep learning. Well, what accelerated this getting better is like, you know, the first translation that launched in Google Translate was done on RNNs, and it bridged like most of the gap to human performance. But then there was this transformer model, and the transformer model really helped train way more in parallel, put way more compute at this same time, and it scales. Like you can train it on a lot of internet. I guess everyone here has heard about the transformer, but the first results were just on translation. And you know, it took a lot of work to get these blue scores up, and with transformer you could have a smaller model and they went poof, right? They went up a lot. So one common topic is, you know, more data, more compute, better results. And then, well, people started believing in it. And when you believe in it, then you take all of the internet and try to just train to predict either the next word or some masked words like bird or images or these days videos or audio. And it works, right? You scale up, models get better. But then you reach a phase where like, deep learning used to be like, oh, I launched this learning rate and that and this batch size, and I try to tune my parameters. So I'll run it 10 times and one will be really good. But you can't do this when your one run costs $10 million. So there was the scaling law papers, which was really important because it showed you, oh, like if you run small models, you can actually predict what the big model should be. So if you're like not great, you know because the dot is not on the line, it's somewhere else, right? And it turns out the first line was actually wrong, but whatever, we fixed the line. And now, so this tells you how you can do one shot, one big run. You do a lot of small runs, but then you do one big run and you know that it will be really good because it will be on this line. Yeah, so that's amazing because with this you can train like a super huge model, say GPT-4, and how do you make this model? It's a language model, so it just predicts the next thing. So you still need to do a little bit of something to make it answer your questions. That's called RLHF. So it's like reinforcement learning tuning. And then this parsing paper, my first paper took like a lot of work to get the data for ChatGPT. You say, well, do you know what constituency parsing is? It tells you nicely. And then you say, hey, can you parse this thing? And okay, John has a dog, probably it has seen its training data somewhere, right? So maybe it has memorized that. But then you can take a sentence from the New York Times. So you just say, hey, can you show me the parsing tree for renewed concern about the health of the banking system right down the stock market on Friday? And you got this. And you see, like 10 years ago, this was unthinkable because there is no data, right? It just did it. It quite certainly has not seen this sentence, but it has learned the algorithm of parsing without any special training for that. It probably occurred somewhere on the internet, but it just learned, right? So that is quite amazing. Like it shows that these models can generalize, and generalization is the second thing. So you can put a lot of more compute and money into the models, and now we know how, but you need a lot more data. The data is kind of running out. Like even if you scrape more of the internet, it's maybe it's not the data you want, because what you want is not to answer questions about the next Q1 on forum. You want to answer questions about what people really want to do, and some things are just not on the internet. Some things are internal, some things are just small and people only learn them from books, whatever. But this shows you that these models do generalize. So maybe you can use just a little bit of data and make deep learning good just by injecting compute without this huge pile of data but you still need a little bit, but of just the right data. And I think this is what the future will hold. One thing that is not very well noted, so the Attention is All You Need paper had results on translation that were very noted. It had a little section on parsing at the end. And what many people never noted is that the transformer is way more data efficient. So RNNs never trained very well on the pure 40,000 data set of parsing, while for transformer this is totally enough. So a better architecture can generalize better, and then you can ask yourself the questions, can we do something that will generalize even better? Maybe recurrent architectures. We worked on them a lot. They work a little bit, but maybe not that great. But there is something these days which is actually a recurrent architecture in disguise, which is called chain of thought. So chain of thought is, you give the model a question, and instead of just getting the tokens of the answer, you say, well, think a little bit in tokens, and then give me the answer. And I believe this is great. I mean, for people who do theory, transformers with chains of thought are Turing complete. So finally, this is the ultimate architecture, at least in this sense. And there was a paper by OpenAI, can you improve chains of thought? Like, normally people just few-shot prompt it and like, okay, think. But it doesn't know how to think on its own. And the few-shot prompting only tells it a little bit. But can you train it? Can you make it better? And step by step, it starts to seem like you can. And if you teach the model to think, then your more layers, we're getting better generalization, longer thinking, more tokens will give you even more. And in this way, you'll achieve something where you can put a lot of computation with just a little data, maybe a few examples, a few things telling you what's correct. You need to give it context. You need retrieval, you need, it needs to know your emails, it needs to know your documents, maybe it needs to know your internal knowledge graph. You need to point it like this data for RL needs to be good. It's not the trillion tokens of the internet. But when you do this, it's like the more layers give us the big thing of computation and data, more tokens will give us the same with just more computation. And I think, the models will become intelligent. We do that. So thank you very much. Looking forward. Questions? Sure.
There's a second mic if someone wants to ask Łukasz a question.
I can start. Hi, great talk, amazing work. Years of amazing work, actually, big fan, you know that. So, question. So this is very interesting. Actually, I didn't know that paper about the transformer asking and to be compared. But I wonder, what do you think about Llama 3? Like what they did recently with the training. This is quite fascinating. That first there is this, huge training phase, then there is supervised fine-tuning, then there is reinforcement learning with human feedback, then there is direct preference optimization, right, and so on. So it also shows that there's layers and layers of training, right? I just wonder from that perspective, right, where it's going.
I think you need to get to a point where you can take little data and put a lot of compute. So currently the whole post-training phase, RLHF and so on, it's like 1% of the training in terms of computation. I think you need to get to the point where it's the same or even more. And then the models will just be. On the data you'll do this, they'll become, it's like AlphaGo, right, or AlphaFold. You put a lot of computation into checking possibilities on a smaller number of tasks. But it's a path. You need to build.
Do you have new methods for fine-tuning are coming, or the ones that we've got are sufficient?
It's all RL, right? But what RL is?
Yeah. Right. Cool. Thank you.
So you mentioned essentially that doing an inner monologue is going to be better, right? It'll think through things, and then you have more tokens. And so what I've been seeing a lot is you have a second model as a judge of what the first model is trying to do, and that's essentially the same thing, right? Like you're adding another model, it's more tokens, you get a better answer. Is that a good implementation, or do you have a better way of using more tokens?
Yeah, it's all in this vein, but as in deep learning, there are tricks to everything, but yes.
Okay, one last question. Oh my god, I need a coin, so I'm just right-handed.
Thank you. Thank you for the talk. What do you think about diffusion models? Do you see a merge between after regressive LLMs and diffusion models in some way or another?
I like diffusion models very much, but I haven't seen them take over for text yet. But
maybe their ability to refine their output is valuable or not.
It's a great ability, and for videos and pictures, it's amazing. But for text, it doesn't yet. Yet.
Yeah.
So we say
Thank
yet
you.
to deep learning.
But what if, I think is it kind of additional question to diffusion model, what if LLM made an error and how it can change the process of thinking into correlate itself and to say okay, I made a mistake, let's kind of just cross the line, it wasn't correct, and continue from something else.
So that's the great thing about the thinking. Because it's not output, it can say, well, I want to say this. Oh, wait, that is a mistake. I'll say something else. Let's just cross that out, but it doesn't need to cross it out. It just thinks, and then it can just say, oh, I made a mistake, right? That's what it can do in thinking. So it solves this problem in a not very economical maybe way. Maybe diffusion can solve this better, but it does solve it. So.
Oh.
Thank you very much.
Thank you very much. Round of applause. Thanks, friends. Thank you, Łukasz. And, 2 mics. All right. And now we're having our second speaker. So actually, Łukasz and Jan worked at Brain together. Jan is the CTO of Pathway. He's a deep learning researcher who was at Google Brain, Mila, and actually he raised his hand when Europe's question was asked. So yeah, over to you. We're going to talk about RAG and indexing.
Right. Thank you very much. So Łukasz set the stage very nicely for what's going to come. So he was speaking about making those models know the context. So if he's working on how to make the models make better use of the digital data that you feed to them, I'll try to take you on a journey of how what's necessary to basically better feed the models with the appropriate context, right? So I'm not from here, so of course I like San Francisco landmarks. So let's say that we stand on the left-hand side of the bridge and we want to reach the foggy area and come up with an idea what's going to happen in maybe a couple of months or maybe even a couple of years for those kinds of architectures. So basically, not how the LLM, the language model is going to evolve, but how the usage patterns of using the LLMs are going to develop over the next couple of months. But let's start with the very basics. So half of you raised their hands about working with LLMs, so maybe just to remind you a little bit what the LLMs are good at and what they are bad at. So they are basically perfect at manipulating words. They are taught to manipulate words, all the training process about the word manipulation, and they can reason with words, right? They can reason without using words. But what they don't have is basically the private data. So they are very good with, let's see if this one is better. So they are very, very good with common knowledge. But for various reasons, we don't want to put our private knowledge into LLMs. We want to feed it in some other ways. And hence, they basically need tools to answer beyond the common knowledge on which they were trained. So if they are trained on all of the public internet, there is the hidden internet that they are not trained on, and they rely on external tools that we have to build around them to be able to talk about it. And the most basic tool is Retrieval. So there are many tools that they can use, but there is one tool which sort of took the stage because of its efficiency and simplicity, and this is the Retrieval Augmented Generation, a very simple 4-step process that we will try to, of course, complicate. But the basic one is you get a question, you search a database to retrieve useful facts. If you read a typical, cookbook on the internet, they would tell you that to use a vector database because the neural nets, of course, they use little vectors. But we'll try to talk about this. You have the facts. You basically concatenate them into a huge string, right? You tell the dear large language model, given that this is what I found in my database, could you please answer this question? Be concise. And this is called prompt engineering, right? One of the hottest job profiles that you can get. And then the LLM answers. And in this way, basically, you have primed it to answer using your private data. So you start to have those two systems. The LLM, which is doing the word processing for you, and the retrieval system, which feeds the LLM with the data on which it should be working. And we can try to juxtapose the two systems together. So what are the characteristics of basically retrievers versus LLMs, and are they the same? Well, are they not? So one thing is easy because I said it right. The retrievers deal with the world of facts, so they are your knowledge base. Whereas the LLM deals with reasoning, or at least we tend to personify our tools, right? So if you ever argued with GPT about something, then you could say it reasoned with you. We could also say basically that one is memory and one is processing unit. So if you want to draw the analogy to how a computer works, then basically the RAM is the retrieval realm, the CPU is the LLM realm, right? So memory versus processing unit. But then there comes another distinction. Retriever is engineered. We know what it's supposed to do. We can write a proof about what it does. So we can say, okay, retrieval out of a hash map is O of 1 complexity, right? Or if you use a B tree, right, is n log n. So we can do this kind of reasoning, and it's programmed. It's also simple. in the sense that we know what it's doing. It's composed of little blocks that we understand very well. On the other hand, the LLM is complex. You don't program it to reason, you teach it or train it to reason, right? If you have errors in your database, it's kind of easy to correct. If your LLM makes an error, you resort to what? You add at the very end of your prompt, and please, please, please send me a JSON. Please, pretty please, use 10 words or less. Please, pretty please don't argue, just an answer. Or please, don't say you don't know, just answer. And I've seen it, a few of you are laughing, so I guess it's lessons from the trenches, right? Maybe not that much please because you pay per token, but in general, this is how you try to fix the system. And this tells you a lot about maintainability of this, and if you ever deploy a production model, what do you do as the poor engineer tasked with fixing this for a client? So the retriever is in the land of easy updates. You have your CRUDs, your creates, updates, deletes. Someone tells you, oh, it's GDPR data, you have to remove this guy. Easy. How do you remove the knowledge of how to make a bomb from LLM? It's hard, right? They are trying, and there are whole teams dedicated to erasing knowledge that happens to be in the training data, and it still doesn't work, right? They will write poems about stuff they shouldn't, they will tell jokes about stuff they shouldn't, they will generate you QR codes that will decode to this information, they will do ASCII art. There are ways and ways to basically overcome it, which basically shows you how tough it is to manipulate knowledge once it sits in the weight of an LLM. So the retriever is engineering, the LLM is magic. Alchemy. And finally, they are used in a different word. So the retriever typically is mostly active when you put data into it, right? It has to read all of your documents and then store them, index them. The LLM right now is mostly used when you have a question to answer, right? You don't really try to, well, you can fine-tune the LLM, which some people do, but most of the time you call it only when needed, whereas the other part is active most of the time. So there is a definition of how the two systems are accessed. One is, we could say, on the write code path. Whenever new data comes in, you are proactively writing into your index. The other one is on the read code path. Whenever a question comes, you are reading out of it and don't touch the thing otherwise. So different, basically, build different engineering background and then different use. And what I want to say today, that the retriever is basically more than what's in the cookbook 101, so more than vector search. It's not only more than vector search that you can, use something fancy like BM25. Who knows what's BM25? Okay, about 1/3. So who knows what's WD40? Degrees, right? So they share one thing. WD40 is the 40th degrees they tried. BM25 is the 25th retrieval scoring function they tried. And this is the classical information retrieval function. It works really well. Who has heard about the needle in the haystack benchmark, for instance? Right, so they think that Google overfits to because someone tagged them on Twitter. And the whole thing is in a body of text, find the sentence, the magic number in the magic city is. And it's extremely easy for computers to find a sentence, which is like a regex, by regular expression. It's hard for the neural systems. So one complexity in the retriever is that you don't want this to be all this fuzzy synonym matching vector thing. Sometimes you just want to have your quote-unquote parentheses kind of a question, and you can use classical tools for it. Graph indices. You can take a body of text, run it through an LLM, get a graph of interactions. This is a very, very compressed view of the information. Maybe you can basically use it to better retrieve facts, right? You're searching for information about someone, and then you search about his friends, his company, and basically you're traversing the graph. So it's another kind of index that you can use to build a better retriever. So the retriever doesn't have to be this basically vector search or matrix multiplication, basically. It can be something heavier, better engineered, and all of this will translate to better answers, and all of this will basically translate to a system which is easier to maintain, cheaper to run. The better the retriever, the better the answers that the model is producing. And knowing what they do, what's the relationship between basically a retriever and an LLM? Are they separate? Does one have to always come before the second or no? And I believe that there is this sort of yin-yang, one is the other relationship between them. So they are not really opposite, they are more complementary. It's for you to draw the line. For me, it's a little bit how the applications are related to databases. We have the talk right now about using SQLite on the edge and whether it's a good idea, because the database somehow they grew to have procedural languages inside of them. So if you want to have a database which operates fast, it needs to have a little bit of PL Python inside of it. If you want an application to run fast, you need to have an embedded database. So if you want an LLM to run fast, it needs to have a retrieval component. If you want your retrieval to run fast, it will need to have some sort of LLM processing. I would say that it's natural order of things. So the two will be intermixed. A little evidence for this. If you make a retriever LLM aware, so if the retriever knows for which LLM is retrieving data, you can generate easy savings just like that. We did a very simple thing. You basically say to the LLM, please answer or say no, and then you give it more data. And this allows you to save costs. And this is the extremely basic scheme which is beyond this 4-step RAG. Retrieve, make a prompt ask. It's basically retrieve, make a prompt ask, make a second prompt ask, make a third prompt ask. You get savings. And it's good, right? Because I read somewhere that every AI startup is losing money, right, on GPUs. So this helps to save the GPUs directly. We believe at Pathway that since the LLMs and retrievers will be more intermeshed together, we need languages, we need tools that allow you to write two kinds of code, right? You want to mix the LLM with retrieval, you want to mix stuff on the write path with stuff on the read path. So you want to be able to write a preprocessor which uses LLMs to better store the data. You want to have LLMs that will be doing better retrieval at runtime. So if the transformer could pause and just fetch a little bit more facts and then restart, probably would also, you could say that this is an infinite context length, right? Rather than doing the very dense matrix multiplication with the GPU, just call it a little procedure and fetch the data as needed. And it's cheaper. So basically we are developing tools for this. We believe that those two words will intermesh, and it's up to the application designer where he draws the line, what's best for them, but it cannot be this arbitrary, these are the 4 steps, and here's what you do. So where are we with this today? We as the company Pathway, we are making a tool for real-time data processing. It can take all kinds of different data in, including your documents and graphs. It has support for this query and response loop. So you can implement the right path on it, you can take your data, ingest it, index it, but you can also use it to answer questions. So you can use it as basically an interactive query processing tool. It can call into external models. So you can, for instance, very easily implement something like take those documents, parse them, extract the entities, make a graph. When retrieval, traverse the graph a little bit. You can also store it somewhere else if you like to use an external database. And it's super easy. How easy it can be? Well, for instance, this is I took away some of the imports, but basically you can read your data or S3 or Google Drive, make a very basic index or 2 or 3, mix them together, and then call into a query answering system. So create a chatbot just like that. And the beauty of this is that we take care of the write updates for you. If the files change, we will change the index, we will change the answers. You will get your knowledge in real time up to date. So this is for you to think about how to index data, for us to think about how you want to update it. So how do you want to have this fresh? But we believe that it's only the start of the journey. So the tightening between the retrievers and the LLMs will be happening. It will be happening to get lower latency, right? If you can move the two to the same place, if you can move the two to the edge, everything will be faster. It will require some reimagining how the negotiation between the CPU and the GPU work, how the communication works, because the retriever is more on the CPU, sort of if land, the LLM is more on the dense matmul land of the GPUs. And basically we would want you to take this journey with us. So there are examples of how to use it at pathway.com/developers, but we also have a very special offer in sense for you today. If you would like to build your LLM application with us, please scan this QR code, fill a form. We want to dedicate a week of engineer for qualifying basically projects. So please do it. If you miss this, there are QR codes all around the room. You cannot miss them. So please do it, and we really would want to explore how the next generation LLM applications will look like with you. Thank you.
Awesome, thank you. So I guess we can take a couple of questions, or we do them during the panel. No, what do we have now? Yeah, actually, so then we'll be moving to questions for Jan.
Think it was a really interesting talk. My experience a lot index context, and in common, the problem we used in Invention, it's like a competitor to GitHub Copilot, and when you kind of index code, it finds chunks of code, but when, for example, it knows what the code exactly. For example, response for authentication doesn't know that it uses SQS. So it doesn't know kind of abstract layer of how each part is connected to each other. It just knows kind of exactly that specific chunk of asked question. And suppose the graph indexes, it's my answer. And sorry for the mic, I'm really talking constantly, just it was. My question, does anyone try to use the graph indexes? Will it answer my question that it knows, for example, that the architecture is like that thing, and after that it will go to chunks of specific questions?
No, it's a perfect use case because you have this relationship, right? You know that this file imports this file. So if you retrieve from file A, but file A uses file B, you probably have to take the symbols from them and their definitions for the autocomputer to work. And you know that the person is doing something, so there is also the graph of the files that the person has opened, right? So you probably don't want to feed just the relevant code snippets, you also want to feed the 5 other files that the person is editing or was editing in the past, right? So you have this relationship opened in the window next to it, edited past, so and then of course where the symbols come. And I don't know what Copilot is doing, but I guess that they have a more advanced retrieval than just let's index code.
I think it's what you mentioned that they are doing. They kind of take all in the context of the LLM. From my understanding, kind of it's also need to know also architecture understanding of how the application works. It's kind of I suppose graph indexes could work with that, but I see that I need to deep dive into myself.
Yes. Well, you get the graph out of the autocompleter, what comes from where, and you have to use it. So but we do know how to use it. There's a question here.
Hello, thank you very much for this presentation. My name is Marina. I am a non-technical founder of Femispace. I have a clear vision of the LLM I want to build, but I want to understand if it's technically possible. It is in health tech. Basically, what I want to build and train LLM, which will be retrieving data, user data, answering questions, doing whatever it's needed to be trained, but never send it anywhere data. So basically, I want to understand if technology is already in place so that I'm fully compliant with security and privacy of data.
Yes. In fact, if you go to Pathway.com developers, we have a private.
Already
LLM.
applied.
We have a private LLM demo that basically runs everything on a designated machine that the data never leaves it.
So you have.
Yeah, we have the code. We have a demo.
Okay. Already applied.
Cool.
Yeah, actually we get questions of whether it works in a Faraday cage. It works.
Hi everyone, this is Pranay and I work for Walmart. So the question is, first to start with, just wanted to understand the incremental value Pathway would provide on top of having an application where you have an LLM and also a process, more of a RAG process where you have a vector DB something building as an in-house application versus utilizing the experience of Pathway. Just want to understand the incremental value I would get out of it. That's the first question. The second one is any specific use case in e-commerce that you have targeted on was successful.
So the first question is great. What's the value added? I guess it's the reduced complexity of the retrieval. Because if you say, I have a vector database, cool. You have one algorithm for the retrieval, which is not the best. We actually found out that mixing them is better. Then you would want to have two of them, right? So you fire up another database. Then you would want to synchronize the two, so you have a synchronization process, an airflow, something like that. Or you do a lambda, or you do some triggers. So basically, you start to develop a large system to deal with changes such that everything is in sync. And then someone gives you, okay, have file permissions, which is another nuisance, right? Because you have to start checking for them. Then you will say, okay, but maybe I will pre-cluster my documents because this helps. And then you don't know how to handle, say, deletions out of those clusters. So it's very quick to get started with basically a vector database into which you put static data. It's somewhat tedious to make it use new documents. It becomes hard the more pre-processing of the data you put. And we take the pain of doing this away from you. So you don't have basically 10 different database engines glued with lambda functions, triggers, and airflow, all running in batch, right, and restarting from scratch, because that's the easy way to handle a deletion. You just restart. Instead, you have a few scripts which do it for you, and they run in real time. So someone deletes a thing, and you no longer have it.
Just a follow-up question on that. Is it an on-premise service that you provide, or is it a cloud-based?
Both. You can start on-premise. It's basically everything is installable into your computer to get started. If you want to scale it, you can talk with us. You can also scale it on-premise. You can scale it in the cloud.
I still have the same question that's not answered yet.
About the retail use case.
Yeah, we can take it later as well if you want to. That's okay.
Well, we never tackled LLM plus retail, though I know that for recommendations, actually many of the LLM algorithms work. If you have textual descriptions of basically items, then all of the natural language processing allows to do better recommendations. So this would be the first thing on top of my head. And this is, in a sense, retrieval, only without the LLM part. So for this for sure. Mm-hmm.
Awesome. Thank you, Jan.